Zeros of linear functions. Sounds a lot scarier than it actually is. I do need you to write some stuff down for me though. So if you would, this box right here, write this whole thing down. Zeros, roots, solutions, and x-intercepts. All right, now that you have it written down, draw a box around it or circle it, draw wavy lines, put stars around it, draw giant arrows pointing to it, whatever you need to do so that you can find this whenever you need to find it. These four words technically mean the same thing. Each one of them stands for something slightly different, so we do have four different words. But for the most part in algebra, you can interchange these words. So if I ask you to find a zero, that's the same thing as asking you to find a root or a solution or an x-intercept. The problem is, especially on things like the STAR test, is that they tend to switch between these words. So you may have a problem that asks you to find the zeros, and then 4 questions later, you got one that asks you to find the roots. It's asking the same question. They just like to mix up these 4 words. So it is very important that you remember zeros, roots, solutions, and x-intercepts are the same thing. If you're in my room, I have a big poster on the front wall that says zeros, roots, solutions, and x-intercepts. And I will ask you periodically throughout the year, hey, what's the same thing as a root? Or hey, what's the same thing as a zero? You've got to remember this. 2 more things of note here. First is parent function. A parent function is the simplest form of a function that still has all the characteristics of that family of functions. So far, everything we've looked at is linear, and today will be linear also. You see the linear parent function here is f of x equals x or y equals x. And remember, those are the same thing. That is as simple as I can go and still be a linear function. If I go any simpler, I have to start either getting rid of the y or get rid of the x, and then it's not a linear function anymore. If I add some extra stuff to it, it's still linear, but it's not the parent function because it's not the simplest form. I can also change forms. If I wrote y equals x squared, that's not linear anymore. That graph does not make a straight line. In fact, it makes a curve. So it's not the linear parent function. In fact, it's not even linear. It's actually the parent function for a quadratic, which we'll do later. Okay, for today, all these are the same assignment, asking you to do the same thing. Find the zero of each function by graphing. Well, how are we going to find a zero? Well, since zeros are the same thing as x-intercepts, all we really have to do is graph the line and then see where that line crosses the x-axis at, and then we have our zero. So what I want to do is I want to graph f of x equals 3x minus 3. To do that, we're going to do like we did in the last lesson, and we're going to make a table. And we're going to take that table and put the dots on the graph and then draw a line through it. I want this line to be as accurate as possible because we're hunting for an answer. So if you notice my little fancy table here, my little fancy table has an x just like my normal table does. Over here it has f of x. Well, that was y. Remember, f of x and y are pretty much the same thing. So that's my x and y values. I used f of x because the problem uses f of x. The only difference then is this table has this function column that runs down the middle of it. So just like last time, we're going to pick an x value. You can pick anything you want to. You know me, I like to start with 0. I like to start with 0 because it's usually the easiest thing to solve. My graph also goes by 5s. So if I start in the middle and count right, there's positive 5 on the x. If I start in the middle and count left, there's negative 5 spaces. So I don't want to pick a number outside that range, nothing beyond -5 or +5. So 0 is right in the middle. It's going to work good. So what is my function? So my function is just my equation where I plug the 0 in. So notice it says f of x. Well, now my function is not f of x. My function is now f of 0 because I'm plugging in 0. That equals 3, and instead of times x, it's now times 0 minus 3. So to get the f of x value, I need to actually solve 3 times 0 minus 3. 3 times 0 is 0, and 0 minus 3 is -3. So my point, my coordinate, is now 0, -3. So I want to go ahead and graph that. 0 on the x-axis means we do not go left and right at all. -3 on the f of x or y means we go down 3. So there should be a dot, if we did everything correctly, right there. That's 0, -3. Let's pick another point. How about 1? Because we just want to be easy. Then my function is now f of 1, because we picked 1, equals 3 times 1 minus 3. To find my f of x, we need to do the math. What's 3 times 1 minus 3? 3 times 1 is 3. 3 minus 3 is 0. So I have a point at 1, 0. 1 is my x value, so I'm going to go to the right one, and then 0 is my y value, which means I don't go up and down at all. So I should have a point right here. Let's pick another point. Let's get really fancy, 2. If you're feeling extra, you're welcome to throw negatives in there or fractions. I don't know why you would do fractions. Please don't do that. But technically you could. All right, my function now is f of 2 equals 3, parentheses, 2 minus 3. And to find my f of x, we're going to do 3 times 2 minus 3. 3 times 2 is 6. 6 minus 3 is 3. So I have a new point, and that is 2, 3. So I'm going to go 2 in the x, so 2 over to the right, and then up +3. And I have a new dot right here. And I do like to graph the dots as I go, because if I'm graphing the dots and something gets off, then I know I messed up and I can fix it right there. So if this green dot was, over here somewhere and that doesn't line up with the other two, then I know I did something wrong. Okay, let's pick another point. How about 3? Now we're going to do f of 3 equals 3 times 3 minus 3. 3 times 3 is 9. 9 minus 3 makes 6. 6 doesn't fit on my graph. If I go over 3 spots and go up 6 spots, that's up here somewhere, and that does line up, but since I don't have graph, I am just kind of guessing, so I don't want to do that. So this is not a usable point. In fact, there are no more usable points. If I go bigger than 3, we're definitely going to be off the graph. And if I go smaller than 0, we're definitely going to be off the graph. So that's it. I can only graph 3 points on this, unless we did fractions, but we don't want to do fractions. Then I'm going to have to stick with these 3 points. So I'm going to get my ruler. I'm going to line these 3 points up as best as I can. Draw a line through. Now my little marker is like less accurate at the bottom of the screen for some reason, so I kind of missed that point. But we can see, since I'm looking for a 0, and a 0 is an x-intercept, well, there's the x-intercept. That x-intercept is at 1, 0. So what is my 0? 1, because it is at the point 1 on the x-axis. Okay, so we're going to do the same thing, but I wanted to show you this because people always get super confused, and this is actually a really easy problem. I love these. Let's pick a point. I'm going to pick a point 0. We're going to put our function in. F of 0 equals -4. Okay, so it equals -4. So I have a point 0, -4. So 0 means no left or right. I'm going to go down 1, 2, 3, 4. And there should be a dot right here. Let's pick another point. Let's pick 1. Well, f of 1 equals -4. So that's -4. And I don't know why it went all weird like that. -4. So 1 means over 1 to the right and then down -4. So that's somewhere in here. Let's pick another point. 2. That's going to be f of 2 equals -4. So that's 2 -4. So I go over 2, down -4. It's going to be somewhere right in here. Hopefully you're seeing a pattern, right? There's no x in the problem. It's just -4. If there's no x, then my x values aren't changing. If my x values aren't changing, then my y value is staying the same, and it's always going to be -4. So I don't even have to make a table. I know all of my dots are going to do this. And we actually end up with a horizontal line that looks like that. Well, because it asks us to find the 0, right? Well, the 0 is where the graph crosses the x-axis, because zeros and x-intercepts are exactly the same thing. This doesn't cross the x-axis. The x-axis is right here. And the x-axis and this blue line, they're parallel. This blue line will never cross the red line. And there is no solution. There's no roots, no zeros, no solutions, no x-intercepts, because it does not cross ever. Okay, one more time. We're going to take our equation. We're going to pick some x values. Guess what I'm going to start with? 0. For my function, f of 0 equals -0 plus 4. Well, you can't have a -0, so that's just 0, and 0 plus 4 is just 4. So I have a point at 0, so no left or right, and then 4 in the y, so up 1, 2, 3, 4 places. So I have a dot right there. One. F of 1 equals -1 plus 4. -1 plus 4 is 3. So I have a point at 1, 3. So I'm going to go to the right 1, and then up 1, 2, 3. Let's pick 2. F of 2 is equal to -2 plus 4, and -2 plus 4 is 2. So I have a point 2, 2, so I'm going to go right 2, up 2. I got a dot right there. 3. F of 3 equals -3 plus 4. -3 plus 4 is 1. So I'm going to go right 1, 2, 3, and up 1. Got more spots, so let's keep going. 4. F of 4 equals -4 plus 4. -4 plus 4 is 0. So that's 4, 0. So I'm going to go right 1, 2, 3, 4 places, and then up and down none because it's 0. Let's do 5. F of 5 equals -5 plus 4, and -5 plus 4 makes -1. So I have a point at 5, so count over to the right, 1, 2, 3, 4, 5, and down 1, and there's a dot. Now I've run out of function table, so I guess we can quit there. I need to take my ruler, see if I can get it lined up as best as I can. Oh, my ruler moved on me. Okay, there's my line. But remember, the question is find the 0. 0 is an x-intercept. X-intercept's right there. So what's that value? 1, 2, 3, 4. So my x-intercept, which is the same thing as my root or my 0, is 4. A few things about this. I always start with 0 because 0 is just a really easy number to work with. But you also remember that we looked at the graphs. So if 0 isn't on the graph, or if it's outside the range of the graph, or if you plug a 0 in and it gives you a number too big or too small to fit on the graph, then 0 is not usable. 0 is not always the best number to start with, but if you're within doubt on what to do, you can always try to start with 0. Also, the more mathly inclined will notice that every time we do this equation, no matter which problem we're working, when we do the function, that every time we get a 0 right here, this number is my root or my x-intercept. Well, if you remember graphing intercepts, the y value is always 0, so that's true. You can't just go off the table, though, because sometimes you're not going to be able to get 0 to show up on the table, and you need to graph the line. So make sure you practice graphing the line.